Okay, as promised, here is the walkthrough for that proof that we were dealing with at the end of class on Wednesday. And I did have to make the adjustment here over. I had to fix the typo that is not on your paper, but it is on my screen. I didn't want anybody to get confused. So our goal is to prove that triangle AB, or that quadrilateral ABED, is a parallelogram. And we've got the given information there on that. We've got an isosceles trapezoid, and we've got a pair of congruent segments as well. So we're going to go through this. It's all pre-written, so you don't have to watch me write it out. Should be able to go fairly quickly. But there are a good number of steps in this one. And what I'll try to do is every time I'll put a reveal a step and a reason, I will put the marks in that I can as I go. So first things first, right? We've got the given statement that that ABCD is isosceles. I did have to kind of paraphrase a little bit in these statements because I wanted it to be somewhat legible. So we know that we've got an isosceles trapezoid. Given information, what does that allow us to say? That's really when we get these proofs, when we're doing these proofs, when we get a statement like that, what does it allow us to say? What does it allow us to put in there? Well, if we know we've got an isosceles trapezoid, we know that AB is going to be parallel, or congruent rather, to DC. So I'm going to put the marks on right here, that because that's I know that the legs of isosceles trapezoids are congruent. That's what I wrote out. If you wrote definition of isosceles trapezoid, for me that's fine. I don't know what other teachers might do in the future. Who knows? But I get what I knew. I would know that you would get it from that, right? What else can we determine by knowing the fact that ABCD is isosceles? Well, we can make a statement about some angles too. We know that angle B is congruent to angle C, right? Because that is the definition. Base angles of isosceles trapezoids, that should be a trapezoid, it looks like a triangle, is congruent as well. Again, I'm just putting information in as I know it. And lastly, I know it's a trapezoid, so I can say that AD is parallel to BE. Now I could say it's parallel to BC as well, but I know it's parallel to BE is for the same the definition of a trapezoid. I know E is contained in segment BC, so it's also AD is also parallel to BE, and that's one of the things I'm trying to get to, right? I'm trying to get to this idea that we are dealing with parallel sides. That's one of the characteristics of parallelograms. I know a lot of us wanted to try to say that, oh, I can say that based on this, right? I know that DE is congruent to DC because that's given information. And since I know that DC is congruent to AB because it's an isosceles trapezoid, that DE and AB must be congruent. They are, but does it really help us all that much? Well, not really, because I'm going to have a hard time trying to prove that AD is congruent to BE. I'd much rather try to prove that AB and ED are parallel, because that's what I'm going to do here. So if I'm given information that DE is congruent to DC, that tells me that I've got an isosceles triangle here, and that this triangle here off to the side is an isosceles triangle, which then I'm allowed to say, okay, well, I know that DEC and angle C are congruent because that's what they're base angles of an isosceles triangle, and they're congruent. So now I'm starting to look at this and say, oh, well, I've got a statement here that says DEC is congruent to angle C. I go back up to statement 3, and it says that angle B is congruent to angle C. Well, then I'm allowed to say, and I've already got it marked, I don't have to do anything different, but now I know that angle B is congruent to angle DEC. That's the transitive property of congruence. If B is congruent to C and C is congruent to DEC, well, then those B and angle DEC must be congruent to each other. So I've got a pair of congruent angles here that also happen to be corresponding angles. They're corresponding because they are formed by what appear to be parallel lines and a transversal. Well, now that I know that they are congruent, I can say with certainty, and I'm going to put 2 marks here, that AB is parallel to DE, because that's the converse of the corresponding angle postulate, I think. I forgot to, I'll just write that in there, postulate. Not super important, but if you knew something along the lines that if I knew the converse, if I know the corresponding angles are congruent, I can assume that the lines that form them are parallel. That's fine, right? And now that I've got that statement in there, now I can say that a quadrilateral ABED is a parallelogram because opposite sides are parallel. That makes it a parallelogram. And this is what some books will do this. They'll actually go and include, they'll include the statements, number 4 and number 9, so you can kind of they can reference back to their own proof as to why we know that to be the case. As tempting as it was to try to go prove that opposite sides being congruent would make it a parallelogram, what we had information for was to get to angles. Okay, so that being said, this is a good challenging problem. Lots of things going on. You need to remember about a lot of properties, not just trapezoid properties. You have to keep in mind that, well, we've got these isosceles triangle properties as well. You've got the transitive property. You've got the parallel line properties. That's why these types of problems are going to be your level 4, because they're not super obvious. Let's just do what we're currently working on and call it done. No, we gotta synthesize. We gotta bring together a lot of ideas, including what we're currently working on, but also stuff that we've done in the past. Yeah. So that's the walkthrough for that proof of proving that ABED is a parallelogram. We got to it at the end of class. Again, once you get statements like you have here, right, when we're talking about statement 1, when they tell us we've got an isosceles trapezoid, what information can we pull from that that's going to allow us to put marks in there and mark up the things if you can. There's no reason not to, because sometimes it's easier to see things visually than it is in written form. Well, I hope this helped. Please let me know if you have any questions.